spread across the globe, but majorly, focusing on the APAC. And it is spread out in various in various kind of products. So they have paints which are solution based. They have paints which are solvent based. They have n number of ways of packing their products, and their movement is pretty streamlined. Their expectation was that they have 36 manufacturing plants spread across India, and they have their own distribution centers. The demand of which was being driven by the retailers, right? So they have their own algorithm, which was basically telling that at a particular day, what is going to be the demand of a particular product, which needs to be serviced from the manufacturing plant. So for this particular implementation, we were talking about the first leg of the movement, the primary movement, where it was the movement from the manufacturing plant to the distribution centers. Now, when it comes to manufacturing plants and the distribution centers, like I said, the quantum was very huge because the production is happening at a very large scale, spread across the country with their own region-specific transportation requirements as well. So I will talk about that. The another very important aspect of Asian Paints was that the number of trips that was scheduled, that was planned for the day. So since this particular business is spread across, like I said, and it probably is, the retailers are probably in every corner of the country. That means that the demand at these distribution centers are very dynamic. They are being, the request comes in very dynamically, and the quantum of the request is really, very, really huge. So the only way of doing that is that the number of trips which are happening has to be very high as well, right? So in a particular day, the number of trips was more than 1,000 trips that was going around, from manufacturing plants to the distribution centers. This is not taking into account the transportation from the manufacturing plants all the way through to the retailers. That is a separate topic altogether. Today, we're going to focus on the first leg of the transportation, where we were building up the stock transfer movement from the manufacturing plants to the distribution centers across the country. And again, given the scale of the operations, the revenue was last year, the revenue was reported to be $4.28 billion, and it's still one of those companies which heavily invest on their IT structure, right? Which is why they had that appetite, they had that IT intelligence to understand the solution which we're providing and to incorporate that. And that is why the robustness of the Asian Paints in their IT landscape also helped the adaptability of the solution. We were able to push a solution, and it was being adopted by the ground users at a very nice scale. Any questions here?
No, please go on.
Okay, sure. All right. So I have talked about how the transportation, we're talking about the first leg of transportation, which is going from the manufacturing plant to the DC. Over here, they had major constraints on how a particular transportation or a particular truckload is going to be built, right? So over here, their major problem was the truckload building, and the truckload has to have a balance of the loose picks and the partial pallets. It had to have the balance of the different kind of packagings. Also, it had to have the limit on the unique SKUs which are being put onto the truck. Then, like I said, since the demand was being driven by the retailers and the distribution centers were raising the demand, each day there was a particular criticality, a particular priority assigned to each SKU. According to which we had to ensure that the system, whichever system we are using, it picks up those orders which are of a critical nature, right? And then of course they have criteria that the drugs have to be loaded as much as possible. It has to go out to 99% utilization at least. So these are the basic criteria which were being considered during the planning. Now, let's talk about each of them in a bit of a detail as to what the business context exactly was. The first one, like you see on the screen, is basically the truckloads of the loose picks and the partial pads and the full pallets. They were calling it the sortation adherence. The reason was that at the warehouse level, at the grounds, to ensure that the efficiency was really great, they could not, just transport all of the full pallets because the orders which were coming in were never going to be in multiples of full pallets. I'm sorry. Okay. So since the order were never coming in multiples of full pallets because it cannot be that way, we had to ensure that the warehousing team was able to function. Because if, let's say, if I were to just prioritize all of the full pallets onto one truck, that would mean that any subsequent order which is coming, that is going to be a partial pallet order, which means that the picking, the packing, all of those things is going to be a huge task, and that particular quantum of operations on the warehousing would have made the entire operations really, really inefficient. So they had come up with this business parameter saying that according to our previous the case study which they have done throughout their business life cycle, they have come up with a particular percentage of the sortation being the ratio between the loose picks and the full pallets being put onto a truck. So for every order which was going out, they had a specific ratio which they want to adhere to. So they had a window, a threshold window, given the minimum sortation percentage and the maximum sortation percentage, with the ideal percentage in the middle. So that was one constraint. The second was the damage profiling constraint. So like I said, they had different kind of packagings. They had small 1 liter cans being put onto cartons. They had some 10-liter buckets. They had 20-liter buckets. They had 50-liter buckets. They also had gunny bags. They also had, other smaller packagings like that as well. Now they had according to the, like I said, in the business life cycle study, they had seen that the damages were really great unless there is a particular balance between all of these packagings being put onto the truck. So let's say in a particular truck of, let's say if it is a 10-tonner truck, they were putting on a 50% carton products, then 20% 50-liter, and then the remaining as a 20-liter truck, 20-liter buckets. So this ensured that the damages were reduced as much as possible. So again, they had a maximum threshold and a minimum threshold for all of these individual packaging types. So carton had its own minimum and maximum, 10-liter had its own constraints, 50-liter had its own constraints, and so on and so forth. So that was another constraint. The next was that they could not, like from a business perspective, if you think about it, it's not logical that to send just one particular unique SKU onto one truck, right? So for example, if a DC is requesting n number of goods, let's say they're requesting a royal blue color, a red paint, and a solvent-based solvent, right? So they cannot just send the highest requested product. They had to ensure that there is a balance of all of the SKUs, because since the demand is so dynamic, they cannot send just single SKU onto one truck. So what they had done was they had defined a minimum count of the unique SKUs, the unique products which were being put onto the truck. Now, obviously, when on the operations, they might change that parameter as and when they go ahead, right? So that was another constraint as well. Now, the next constraint was really important because that is the major area where the Asian Paints business was facing problems with. Before we started, before the solution was implemented, their truckload was not considering the criticality pickup at all. What do I mean by criticality? Like I said, each day they had an algorithm based on the demand coming from the DCs. Each SKU had its own criticality being marked. So the criticality being marked was from C1 to all the way through to C5. C1 being the most critical, C5 being the least critical, and C0 not being critical at all. All right. So over here, all of these criticality was a major constraint that they had to be picked up according to this. So if a particular SKU is C1, and there I have a C5 SKU, and onto a particular truck, I have a space only to load one more SKU. I would load the SKU which is of C1 criticality. All right. Along with this, there were other prioritization constraints as well. For example, let's say there is an STO which has been on the system for a very longer time. So I would want that particular STO, the stock transfer order, be serviced first. So according to the STO age as well, we had to prioritize the orders being picked up by the truck. Along with the STO age, there was also the delivery date request as well. Because obviously, if the delivery date is, let's say, 2 weeks after, you would want to send out the goods which are requested in the next week itself. So the the delivery date request, the STO age, and the criticality, all of these were playing part in prioritizing a particular set of orders to be picked up by the optimizer to create a particular truckload. And all of these coming together, we had to ensure that all of these parameters are being adhered to. At the same time, it should not let the truckloads being built below a minimum threshold of that utilization. So, like I said, the criticality and the prioritization of orders, before we started, the criticality pickup was less than 50%. But after the solution was implemented, we were able to raise it to 95 to 97%. And we'll talk about how we achieved that. So the first thing which we did was to break down these problems into smaller parts. All right, let's be on this slide as well for a while. For the first one, we incorporated things like we understood that, okay, we have to, first of all, visualize and understand which of the load which is there onto the ground is a partial pallet load and what is a full pallet load. And what quantity, when I'm picking a particular SKU, is it going to be a full pallet quantity or a partial pallet quantity? So whenever I'm picking something up, how do I recognize that the load being picked up is a full pallet or a partial pallet? Thereby, at a particular at an overall level, what is the percentage of the sortation percentage which is coming up? So what we did was we utilized something standard being present in SAP TM, something called as artificial dimensions. We introduced our own artificial dimension, saying if it is a full pallet or not. So we termed it as FP. If it was a full pallet, we were marking it as 1. If it was a partial pallet, we were marking it as 0. Thereby, we were able to recognize and then create calculate that ratio between the full pallet and a partial pallet being put onto a particular truck. Now that is just recognizing what that is, right? We still haven't set the threshold, the windows which I talked about. For that, SAP TM provides something called as load cost function. Although it is by standard, it is used to just push the utilization percentage, where you just tell the optimizer that the minimum utilization has to be so and so. But we use that. We came up with certain mathematical formulas to translate the full the sortation percentage to the load cost function, where you can imagine that function being a function between the x-axis being any dimension. In our case, the artificial dimension which we introduced, and the y-axis being a cost, which is basically pushing the optimizer to pick up load in the least cost way. So that was one thing which we did. We utilized something which is present in the standard, but in a way which has not been used before. Now, the damage profiling was, again, we utilized something which is the TM by standard provides. They provide something called as compartments, where you can visualize a truck being distributed into visual compartments. Although by standard, it is used for scenarios where there are trucks which are, like 50% refrigerated trucks, and then the rest of the space is for ambient goods. Or there are, divisions within the same truck, like in that particular carriage. What we did was, their trucks do not have these physical compartments, but we introduced these compartments as a virtual compartment. So we said, all right, if it is a carton goods, the virtual carton compartment is going to be of 50% capacity. The 10-liter cup, the 10-liter, the virtual compartment for 10-liter buckets is going to be 20% of the entire capacity. So this way, we were able to visually virtually push the optimizer, the SAP TM system, to recognize the products and understand that what is the maximum limit a particular product can be put onto the truck, because I have defined a virtual compartment, and it has its own maximum limit, a maximum capacity which that particular compartment can hold. That was how we approached this, again, using a standard solution available, but using it in a way which is quite different. The limit on the count of SKU, however, was something which was not present by standard in SAP TM. In SAP TM, the only limit which we can put on something like this was the limit on the stages, the limit on the number of stops a particular truck is going to. So let's say in a multi-drop scenario, we have n number of stops. But for some reason, a particular business says that at a particular in a particular trip, my truck can only go to 5 stops. So I will be defining that as a limit to me. But like I said, in Asian Paints, there was no such constraint. And all we had was a single leg transport, right, from my manufacturing plant to the DC. So this particular parameter was still empty and we could still utilize this. So what we did was, this is a bit complicated. What we did was we translated the SKUs into you can say a dummy location. All right. So let's say there are SKUs, SKU1, SKU2, SKU3. I would translate this in the preprocessor in using a custom logic, custom algorithm, saying that SKU1 will be recognized is being translated to a location SKU Z SKU1, then SKU2 as Z SKU2, and so on and so forth. So now when I told the optimizer that you limit the number of locations, it was essentially limiting the number of Z SKU1, Z SKU2, Z SKU3, the dummy locations which are created, which essentially were the reflection of the actual SKUs. So one limit of you can say a challenge in this entire operations, in this entire Asian Paints implementation was that SAP TM's optimizer cannot be changed. We cannot change the inherent algorithm, which means we cannot change the number of planning constraints which we are giving. All right. We had to be very creative and very innovative in with working with only the given constraints which the optimizer understands. So that is what we did. We translated our business problems, we translated the business constraints into those parameters which the optimizer understands. For example, in this particular case, the optimizer understands the limit on the number of locations. So we translated the SKUs into locations, which were then being limited by the optimizer. This again was a benchmark solution because this was ensuring 100% adherence to this particular limit which they were providing. So each of their particular DCs, each of their trucks, each of their routes had their own set of constraints of the values of these constraints. So we were able to adhere to that 100%. The next, the criticality was again one of the major constraints like we just talked about. In this, what we did, by standard, SAP TM provides the entire SAP TM optimizer runs on the concept of minimization of the costs. All right. So the intent of the optimizer is come up with a particular solution, come up with a particular truck load, which had the least cost being incurred by the business and inherently by the optimizer as well. So what we did over here, we said that any product which is marked as a critical product, for example, C1, will have a high non-delivery cost. What I mean is, if this particular product is not delivered, the business, the optimizer is going to incur a very high non-delivery cost, essentially pushing the optimizer to pick up this particular SKU. Similarly, we did a lot of calculations. We had to go through a number of iterations to arrive with those values which were accurate to push the optimizer to first select C1 and then go on the way to C5. And C0, we assigned a very low non-delivery cost, essentially saying that even if you have to pick up goods which have a higher non-delivery cost to it. Now, like the other priority parameters which I talked about, them being the STOH and the delivery dates, they also had a similar approach as well. So the entirety of the particular solution was built around the optimization of the costs. And we were able to translate all of these parameters into terms of costs, which the optimizer was able to understand. Like I said, it understands the non-delivery concept, the non-delivery cost concept, where if a particular order is not delivered, the optimizer incurs a higher cost, which it tries to avoid. So that is what we did. We came up with certain values. We did some calculations and a very thorough testing, a very reiterative testing, which helped us arrive to that particular number. And by the end of it, like I said, when we implemented this entire solution, you can see we were able to move the criticality pickup and the STOH adherence and the delivery date adherence from 50% all the way up to 95 to 97%. And we were able to do some more tweaks, which is very difficult to talk about in such short time, which also pushed the optimizer to create the truckloads which were of a high utilization threshold. So we do not see any truckload being built where the capacity utilization was less than 99%, which again was a very huge value add to the entire business. So like I said, there are a lot of nuances to each of these constraints as well, because you would understand that when you are trying to solve a problem, it's not just that one problem you're solving, you're also solving the problems which are around that as well, right? So for example, when we were talking about the loose picks and the full pallets, there was another, a problem which we faced, where what happens if there are multiple STOs with smaller, with partial pallet quantities, right? For example, if one particular a full pallet can hold, let's say, 100 liters of paint. I have five smaller STOs, a different set of orders, which are of 25 liters each, right? So we had to come up with a solution, right, where we had to ensure that the system is intelligent enough to combine all of these orders to create one full pallet and one partial pallet load, right? So again, like I said, what I told was at a very overview level, given the constraint of time which we have. But each of the solutions have their own nuances and a background and prerequisites which had to be fulfilled to come up to a solution which was adapted throughout the nation for Asian Paints from manufacturing to the distribution centers. So
So,
that is
Shabir, just there is a question on the chat. I think
right.
might be a good idea to answer that before you move on.
Yeah, makes
So,
sense.
question is from Girish. He's asking, did you leverage any bodies for building the logic required to meet the requirements?
All right, that is a very good question. We did utilize some baddies. So, like I said, we cannot intervene in the optimizer algorithm itself. However, the SAP-TM does allow us to intervene. It has standard baddies, which allows us to intervene in the pre-processor and the post-processor of the optimizer. So, what I mean is, these baddies, essentially the pre-processor baddie, it allows you to modify and play with the inputs which are being passed on to the optimizer before it is completely passed on to the optimizer engine, and the baddie which is at the post processing, which helps us modify the outcome which is received after the optimizer engine has given us that. So these two major baddies we used, and apart from that, we had other baddies which we used for, like I said, there are a lot of things going on behind these major solutions, right? So we did some enhancements on the OTR landscape, at the integration of ERP and TM. Similarly, at the splitting and the merging of freight units, or the quantities. So that again was different barriers which we utilized. So this particular entire implementation was heavily utilizing the standards as well as all of the capabilities which the enhancements could provide us. Does that help?
Yeah. Thanks.
All right, great. Any other questions? All right, I'll take that as a no. So I'm teetering towards the end of our talk on Asian Paints, and that is what I've just pointed out on this slide to summarize what we just discussed, right? The major values we delivered, like I said, was the utilization adherence, where we ensured that the trucks were being utilized as much as possible, considering all of the other constraints which are there, right? So, like I said, the criticality fulfillment, the demand fulfillment was a very huge ask, a very important ask, which we were able to deliver along with the other constraints as well. Then we had, since the TM in this case was a sidecar scenario, there were certain constraints, there were certain challenges which we faced to ensure that the STO to freight unit conversion, basically from ERP to TM conversion, was seamless, because they had their own back jobs running to first of all update the criticality and create STO orders. So we had to come up with solutions to ensure that that particular integration is really seamless. Then the planning process was, we ensured that they were not collecting information from many sources, and all they had to do was two simple clicks of the mouse to come up with a particular truckload. And on your right side, you see the improvements which we have put on, what we just discussed in great detail right now. And that is what it is. I think I covered everything on the high level. And if you ever want to, reach out to talk to in detail, please feel free to reach out to me. I think again, I'll be happy to provide you my contact details. So that's it from my end. Unless you have any questions, I'll be happy to take it on. All right, then. I think Shrenik, you will take over now, right?
Yes.
All right, thank you.
Yeah, you're able to see my screen?
Yes.
Yeah, okay. So let me introduce myself before I start. So my name is Shrenik. So I've been working for Stellium for the past 5 to 6 years. So my main focus will be on EWM aspect of it, and my main working area, I would say, is on automation implementations from EWM perspective. So without wasting much time, I would like to dwells into the automation part of it. So before heading into the problem statements and all, so as Shabir explained the client details, so I'll be taking up the Asian Paints as well. So the business, how it runs, you already know from Sayed's explanation. So as he explained from the TM perspective of it, so there is a part where we are going to have a partial pallet and full pallet. So how we can optimize from the warehouse standpoint of it and reduce the human efforts that are encountered while picking these heavy barrels that are there from one area to another for the loose picks was our main problem statement. Okay, so basically our statement was the current operations included the man to goods uh, uh, analogy. So basically, a person has to go to the C class area or the A class area of the materials, have to go and pull up the pallet from the rack, bring it down, pick up the required barrels that are there, which are heavy barrels, has to pick up that and proceed to the staging area. And these, as Sayed explained, they had for a loading, they had a pattern which they had to follow, and they had to ensure so much of partial pallets are always there for them to fill into the truck. Okay, so because of which the partial pallets which are being picked up were more. So every time the main another challenge I would like to bring up is the staging area. Okay, so each time a partial pallet is created, the staging area utilization becomes more and more, and they were actually covering three to four doors to stage for one delivery for one tonner truck. So that was their major problem. They wanted to reduce this from an operational standpoint. They want to reduce this pallet utilization. They want to reduce the human efforts that are there. They wanted to bring in the automation. So so these were the bottlenecks in terms of the operation they had. So moving forward, so because of which there was an introduction of automation in their particular plant. So as you know, Asian Paints is heavily invested in their infrastructure, and they want to bring up as much as automation and reduce the human efforts that is possible. So right now they have around 10 to 12 ASRSs, which are double deep and 15 to 16, 17 heights and 35 depths, which is a huge storage location. Okay, and they have a specific area where they store C-class material where they want to do a sortation. Basically, partial picks storage area is different so that the sortation can happen easily, and the full pallets will directly go from the ASRS to the staging area directly, so that the time required for the loading and the process in terms of warehouse optimization is reduced. Okay, so the main challenge for them was identifying the OEM partner and the logics that they have to bring in to this, so that the human efforts are very less. Okay, and they wanted to reduce the number of pallets at the dock door and increase the efficiency and make the warehouse operations very smooth. So right now they had the another constraint of labor strikes and all, where because of which they had another aspect of it where the labor cannot lift the 20-liter barrels more than 10 times or 20 times in a day. So that was a labor constraint which they had, due to which they had multiple strikes and other human rights problems, because of which they had to restrict this particular aspect of it. Okay, so these are the problem statements they had. So to increase, to have a solution for this, we used SAP EWM MFS as our main driving part of the automation solution. So MFS is a standard SAP EWM tool which is used to integrate with the third-party systems like ASRS, conveyors, robotics, pick to light, put to light, some of them, to name it, which increases the efficiency of the warehousing operation and reduces the human efforts, human errors in a considerably lower amount. Okay, I'll just stop here. If you have questions on this aspect.
So I think there is one question by Girish again. So I don't know whether it is for your part of the presentation or for the earlier one. He's asking Shabir, I think. Was there any integration between SAP TM and EHS for the project?
No, actually, it was TM and the SAP ERP being integrated, nothing else. There was no other integration over here. Although there was one more third-party application they were using for the load visualization, but that was not inherently integrated with TM.
Okay, thanks. Any question for Shrenik?
Yeah. So you mentioned about ASRS. So what is that?
It's automated storage and retrieval system. Basically, a crane storage system inside a racking, which will go inside and pick the pallet rather than a human doing from a forklift or a BOPT.
Okay. Okay, understood.
It's an automated storage retrieval system.
Thank you.
Yeah. So I'll give you a list of the automation technology that we used for this particular project. So one is ASRS, that is automated storage and retrieval systems. Second is conveyors. Third is the AGVs, which we call automated guided vehicles, where is the fixed track sort of thing where a vehicle is placed and vehicle will move around to ease the operations. And the fourth one is the pallet destacker. So the user, the pallets destackers uses, they will load around 20 pallets onto this particular machine, and it will destack one by one and supply to the automated system, so that a single person cannot put one by one pallet and waste the time for doing that. So, and there is pallet stacker as well. So when when they do sortation, where they pick partial pallets and remove the quantity from the partial pallet, and once the pallet becomes empty, it goes to this particular stacker, and where the stacking of this pallet happens. So these were some of the automations that we had, automation technologies that been used. Okay. Moving forward, so I'll come to the main concept of this particular implementation that we had to think through a lot because of the labor problem, as well as the automation that is there, utilizing it to a highest potential and reducing the number of pallets that are being staged at the dock door. Okay. So we divided it into two things. One is called as positive pick and one is called as negative pick. I'll explain you in detail what is positive pick and negative pick. Okay. So a pallet contains 30 barrels, for example. If something is picked beyond 30, it is called as negative pick. If something is picked less than half of it, okay. So for example, I said 30 barrels, right? If something is picked beyond 15, it is called as negative pick. If something is picked less than 15, it is called as positive pick. So why we divided this is because we have a constraint from the labor end saying that they cannot pick so many barrels or pallets, barrels at a particular given day, right? So to reduce that, so we have divided it into two parts. So positive pick is basically a general picking that we do. Whenever order is created, this sortation partial pallet, we already know. We used standard quantity classification to divide the full pallet and the partial pallet. So full pallet would directly go to the from the ASRS to the dock doors, and these partial pallets would come to a particular called as picking or sortation area, where there was a platform, and the conveyor a conveyor would bring this pallet in front of a particular person who is standing there to perform the partial picks. Okay. So once the pallet reaches him, once he scans the pallet, he understands, okay, I have to pick there in the RF screen, we would give that, okay, this is positive pick. You have to pick less than half of it into an empty pallet. Okay. So basically, for example, I told less than 15, right? So the picking quantity is around 30. Picking quantity is around 6, and the pallet quantity is around 30. So what he will do is he will pick the 6 quantities and put it into an empty pallet. Okay, that is positive pick for you. And for negative pick, what we say is, for example, the pallet quantity is 30. He has to pick 24. Okay, so in the picking 24 is a tedious job. So the labor efforts are more because the barrel weight is high. So instead of picking 24, we tell him to pick 6. Okay. So the remaining quantity of the pallet. So 6 he picks and keep it in the empty pallet. And the main pallet which is there, it will be sent to doctor via conveyor, so that the labor efforts are reduced. Okay. So this is the concept we developed and innovated to reduce the efforts that are put by humans there. So we don't have any challenges. So that is one part of it that we had to think through a lot to bring it into the system and into the RF as well, to accommodate all this positive pick and negative pick. Any questions around this? Okay, let me move forward. So in terms of positive pick, what will happen is the picked quantity is put into an empty pallet. So empty pallet will stay there, and the picked pallet, whatever is there, so it has to, the put away has to be done for that particular pallet, because remaining 24 quantities are not required. So on a click of a button, a system will create a putback task to the ASRS. So he just has to click a button, system will trigger the putback task to the ASRS, conveyor will move forward, and it will take back the pallet to the ASRS storage and store it. So that is one concept. Okay. So to reduce the storage from the staging area, what we had done is we had kept a sequencing. So same delivery related pallets should come one after one, so that he can pick multiple SKUs in a single empty pallet. Okay, so for example, these small quantities, as Syed had explained, they had so many retailers that the dynamicity of the requirement is very high. So the quantities will be varying a lot. So the partial pallet quantities which are being requested are also varying. So there might be a case, for example, the order for a colored tin box is very rare. So it will be distributed only to few customers. So the picking quantity of that is very small, which will come for the colorant that is going to be there. So some of these SKUs they had. So we had brought in these pallets from the ASRS into a queue on a conveyor so that these can be merged, and we had given the provision to the user to choose. So for example, based on the physical queue, so if the user finds it that he cannot accommodate more than the current space that is there on the pallet, he can choose to move that particular pallet directly to the dock door and get a fresh empty pallet to perform his next task. Okay. Got the point? Any questions in this particular solution? Okay. So in case of negative pick, as more quantities were less quantity of empty pallet would be there, which has to be done put away. So the cases for rainbow pallets would also be included. Right now, I'm preferring at saying it as rainbow pallets because there are multiple SKUs in a single pallet. So we are referring it as a rainbow pallet. So the number of increase in the rainbow pallets will also increase the efficiency at the dock door. So they cannot right now, the percentage which I said initially that they were covering 3 dock doors to stage a single delivery. Right now, they are doing it in just 1.5 dock doors utilization. Okay, and the performance has increased so drastically with this particular automation. They were able to fulfill the particular requirement in single shift and recover the remaining shifts with just the full pallet picks. So whatever is required, everything was being fulfilled in just single shift rather than running in 3 shifts. Okay. So here, one more advantage is, as it is the man, wherever he is standing, the goods are brought to him by the automation system. The errors which are done by him are very less. Okay. So rather than going and just picking a random product, the efficiency over here is very high. Okay. So any questions from this aspect of the solution?
If anyone has a question, you can actually unmute yourself and ask a question as well. So you don't need to, or you can post your question on the chat and I can ask on your behalf. Either ways is okay.
I know it's a very complicated session because there is a lot of automation that is coming into the picture. And I'm just explaining the logic that we have done. In terms of actual implementation through SAP, we have done it through MFS. There are multiple ways of doing it. One is through MFS and one is through APIs, through third-party softwares that hardware providers provide. So there are a lot of aspects in terms of integration with third-party hardware providers. So if you have any questions on that lines, please feel free to shoot. I'll clear those as well.
So there is a question. Ravi is asking, is warehouse management must for this solution? So EWM, if I'm not wrong, that's what he's mentioning.
You can do an automation solution with just S4 and WM through a third party. The only constraint you will have is you'll not able to utilize the EWM MFS flavor of it, where the brain is MFS and the control, it commands everything to the hardware provider to do it in a certain way. And you have the complete control in EWM MFS. If that control is given, the element, that third-party software, you can always do a third-party integration through S4, through IDOCs, APIs, anything that is integratable. Right now, we have an option from BTP as well. Through BTP also, we can do an integration. Okay, there is no such an hard stop rule. But if you are having a warehouse management system through MFS, it becomes a stronger solution where EWM is in complete control of the picking strategies and put away strategies, as it knows what it is doing. Building it in two systems, if you don't have EWM, you have to build the concept in two separate systems, or else you have to just use S4 as just a storage location where everything will be there, and you can have a third-party system where you will have the warehouse control, where it manages the every aspect of the automation. Hope I cleared your question.
I got it. Without EWM, it will be more cumbersome to do this integration.
Yes, I mean, it would be a more concrete solution where you don't have to maintain two systems as well. For example, if you take a third-party system, you have to maintain those softwares as well. You have to buy those licensing as well. So that is an additional cost, and maintenance of a third-party system is very high. So if you go with EWM MFS, everything will be covered in your license. So you don't have to worry much about it.
Okay, thank you.
So you can unmute yourself and ask a question, Ravi, if you have a question.
I'm clear with so in case if I have any query, I'll ask later.
Okay. I thought you had a question, so no problem. Please go on.
Okay. So right now we have observed a trend in the automation that is in the current. I just wanted to bring how automation is growing in the warehousing. So each and every organization is trying to opt for an automation system so that they increase their efficiency and increase the throughput of their particular warehousing, as the demand is very high. So as you can see, there is a clear spike that we see from 2015 to 2020-25, and we anticipate that this rise is going to go along even more. So if there is a scale so high, and SAP is also pushing through MFS, DMC, there are a lot of aspects that are SAP is also providing, through which you can integrate with third parties as well as automation system seamlessly. That is what the trend is right now for a automated warehouse solution. Okay, and there are some aspects, mainly because of labor shortage. We know in every industry right now there are labor problems and throughput problems and understanding problems, troubleshooting. So these all aspects are forcing the organizations to move towards an automation warehouse. Basically, the main reason, some of the reasons are because of the e-commerce, where you have to push the delivery as soon as you got to your warehouse, because the delivery should be very fast. So most right now we are seeing more spike in terms of automation to deliver these particular high deliverables clients. To summarize this, we reduced human efforts through automation, and the combining smaller pallets and into a single pallet, we have an efficiency of a pallet. By merging 2-3 pallets into a single pallet, we increase the efficiency of a pallet and reduce the utilization of the dock door. Okay, we have streamlined the empty pallet feed as well, because as it is as it is an automated system, whenever on a click of a button, if he says that, okay, my empty pallet, I need a fresh new empty pallet, I cannot accommodate anything new in this particular pallet, by click of a button, automation system will provide this particular pallet to you so that you can perform your operation. So there is no hassle of waiting for a HST guy, not HST guy, a forklift guy to bring a new pallet, place it on there, pick up the old pallet, put it onto the dock door. So a lot of this time consuming activities are reduced. And through rainbow pallet formation, we have covered most of the businesses requirement that are there to reduce everything. To reduce the number of pallets that are there at a dock door. So this is the overall solution that we have provided Asian Paints, and we are inclining these types of solutions to other retail aspects where there is very high volume and high delivery. Okay. That's it from my end, I guess. If any questions, please, you can ask.
I think there is one question.
Yeah.
Which ASRS make was integrated in your project? Sorry about that. I think,
sorry. Yes. We had two makes. One is Daifuku and another one is System Logistics. We have integrated as a Stellium for other projects. We have integrated with Dematic and the leading partners, whatever are there, we have integrated with all the leading partners. Basically, to give you an overview, there was 10 Swisslog cranes, 2 System Logistics ASRSs, and 5 Daifuku ASRSs in a single facility. So we had to integrate with all of them, all three different kind of hardware providers with 3 different kinds of integration flavors, because each partner will require some aspect of change with respect to their internal coding of the hardware.
So if no further questions, maybe we'll just wait for another 30 seconds before we kind of conclude. I know we are already top of the hour.
Thank you.
Looks like no one else has any questions. So thank you so much, Shabir, and thank you so much, for taking us through the presentations. So until we see you again next month for the supply chain and manufacturing SIG, this is Mukesh Gupta signing off. Take care. Bye.
Thank you, everyone. Thank you.